All right, time to dive in. Today we're tackling foundation models.
Foundation models.
Yeah, those AI systems that are basically the brains behind, well, so much these days. Like, I'm thinking those eerily accurate recommendations you get online.
Oh, yeah.
And, well, even things like self-driving cars someday. You
Hmm.
sent over a ton of research on this, and wow, it gets pretty complex.
It does. And I see you're really interested in how they're built and how they're trained, how to get the most out of them, and of course, how to avoid those potential problems down the line. We'll definitely be covering all of that.
Okay, so first things first, you mentioned pre-training a model. What does that even mean?
Pre-training a model.
Yeah, is it like giving a robot a college degree before it even starts its job?
That's a pretty good analogy, actually. Pre-training is about building that baseline knowledge, that foundation. We're talking about feeding these models massive amounts of data, letting them figure out those patterns, those relationships in the information. It's like a crash course in, well, everything.
Whoa, that sounds intense. So you're telling me these models are learning like everything. Doesn't that make them a jack of all trades, master of none?
Well, that's where fine-tuning comes in. Think of it as specialization.
Specialization.
Yeah. So after that pre-training gives the model like this broad understanding, we use fine-tuning to focus it on specific tasks or specific areas like writing code or translating languages. That way we can use that general knowledge it's already picked up and make it an expert in something specific.
That makes sense. So it's like taking someone who's really well-rounded and then giving them specialized training to really excel in a certain field. But what kind of results can we actually expect from this whole pre-training and fine-tuning thing? Like, is it really worth all the effort?
Absolutely. Take, for example, Stable Diffusion. It's a model that was pre-trained on tons and tons of these image-text pairs, and the result is, well, it can generate some incredibly realistic images based on just a simple text description.
Wait, image text pairs? You mean these models can understand like images and language? My mind's kind of blown.
Yeah, it's the power of multimodal models. They can process and understand different types of data all at the same time. After all, that's how we experience the world, right? Not everything is neatly separated into text or images or sound.
Right, good point. But how do they build these multimodal models? What's the secret sauce behind that kind of processing power?
Well, the foundation for many of these modern foundation models is a type of architecture called the transformer.
Transformer.
Yeah. It's been a game changer. I mean, it was only introduced a few years ago, and it totally revolutionized how we approach things like language processing. And the key to its success, self-attention.
Okay, self-attention. Tell me more.
So it's all about understanding relationships within data. Let's say you're reading a sentence, right? You don't just focus on each word individually, you look at how they connect, how they build meaning together. The transformer self-attention does that. It figures out which parts of the data are the most important and how they relate to each other. And this allows it to do some pretty amazing things with things like translation or question answering.
So it's like the model is actually, well, paying attention to the context, not just blindly processing words or pixels or whatever one by one. That's pretty clever. But
Yeah.
I got to imagine, like, building these things requires a crazy amount of data, right?
You are absolutely right. Data is the key when it comes to pre-training.
Data is king.
You could say that. We're talking billions of images, trillions of words. It's mind-boggling. And the craziest part is it's not just about the quantity, it's going to be high quality too. Diverse, representative of the real world, definitely no errors. Think of it like building a house. You need a ton of bricks, but they also need to be strong and well made to make the house stand.
That's a great analogy. So, okay, so let's say I was going to, I don't know, hypothetically start building my own foundation model. What kind of data should I even be looking for? Where do you even start?
Well, first, think about your goals. What do you want this model to do? Once you've got that figured out, then you can start gathering data that aligns with those goals. For instance, let's say you want to build a model that can generate, breathtaking landscapes.
Okay, breathtaking landscape.
You need a massive, massive data set of, well, high quality landscape images from, all over the world, and not just any pictures. You want them to be diverse, showing all kinds of landscapes, different lighting, different angles. The more varied your data is, the more creative and versatile your model will become.
Okay, that makes a lot of sense. But collecting and cleaning all that data, like,
Well,
that sounds like a massive undertaking.
it can be, But there are some resources out there that can help. You've got publicly available data sets like ImageNet, CFAR10, COCO for vision tasks. And for language, there's Lambda, PenTreeBank, Wikitext, and a whole bunch more. And these data sets are massive, and they can be a really solid starting point.
That's good to know. But how do you know if a data set is like big enough to train a really powerful foundation model? Are we talking terabytes, petabytes? Like, I can't even wrap my head around that.
Well, that's where these things called scaling laws come into play. Researchers at OpenAI discovered this fascinating relationship between a model size, the amount of data you feed it, the computing power you use, and ultimately how well it performs. Basically, you can actually predict how much better your model will be by simply giving it more data and more processing power.
Whoa, so it's like a recipe for AI success.
Mhm.
A little bit of data, a sprinkle of computing power, and boom, brilliant foundation model.
Well, not quite that simple,
Yeah.
but you get the idea. These scaling laws are incredibly useful for planning out big AI projects. They help you figure out just how much data and computing power you need to hit those performance goals you have, which is super important when you're dealing with something as complex as foundation
Yeah,
models.
I bet. Speaking of computing power, I mean, training these models must require some serious hardware, right?
Oh, absolutely. We're talking hundreds, even thousands of really powerful GPUs running for weeks, maybe even months at a time. That's where cloud computing platforms like AWS come in. They offer access to massive amounts of computing power, but like on demand.
So it's like renting a supercomputer for your AI project, but you only pay for what you use.
Exactly. And there are platforms like Amazon SageMaker that are designed specifically to help you, train and deploy these large-scale AI models. They provide all the tools and services you need to make the whole process a lot more manageable.
Wow, I'm starting to understand the scale of this. Massive data sets, super powerful hardware. It's all a bit overwhelming. But I got to ask, with all this focus on data and technology, where do humans fit into all of this?
That's a great question, and it brings up an important concept: human-centered AI.
Human-centered AI.
Right. It's not just about building cool technology for the sake of it. We need to be sure that these systems are developed and deployed in a way that actually benefits humanity,
Right.
right? And that means understanding the potential impacts on things like employment, privacy, even our understanding of the world. It's complex, and it's something we'll dive deeper into as we go.
I'm glad to hear that. It's reassuring to know that the human element isn't being lost in all of this. But before we go too deep into the philosophical stuff, I'm curious about the nuts and bolts of actually building these models. What are some of the key technical concepts we need to understand?
Okay, one of the fundamental building blocks is the distinction between encoders and decoders. They're two essential components, especially in those transformer architectures we talked about earlier.
Okay, those terms sound familiar. Remind me, what do they actually do?
All right, so imagine an encoder as this really efficient data summarizer.
The summarizer.
Yeah, it takes something complex, like a sentence or an image, and it boils it down to its essence. It captures the important information in a really compact form. A decoder, on the other hand, works in reverse. It takes that concentrated information and it expands it back out into something we can understand, like translation or a brand new image.
So it's like a secret code. The encoder creates the code and the decoder cracks it.
I like that. And depending on the task, you can use encoders alone, decoders alone, or even combine them in these powerful ways. For example, the BERT model, which is really famous for its language understanding skills, is primarily an encoder.
Ah, okay.
Oh.
And what about GPT, the one behind ChatGPT? Is that an encoder or a decoder?
Well, GPT, it stands for Generative Pre-trained Transformer, and it's a decoder-only model. Its job is to generate text. So you give it a prompt, and it predicts what words should come next. That's how ChatGPT can have those seemingly natural conversations.
Interesting. So different models are built for different jobs. Makes sense. What other technical details should I be aware of?
Well, there's this interesting technique called contrastive pre-training. It's all about linking different types of data, like images and text, by using natural language labels.
Give me an example. How does that actually work?
Imagine a data set with like tons of images and captions describing those images. Contrastive pre-training encourages the model to find those connections between what it sees in the image and what the caption says about it.
Okay.
So it learns to grasp these concepts like a dog catching a frisbee or a sunset over a cityscape.
So it's like the model is learning to see the world through both pictures and words at the same time.
Exactly. And this ability to bridge that gap between images and language is really important for tasks like image captioning, answering questions about images, even generating completely new images from text descriptions.
Okay, I'm starting to feel like I'm getting a handle on this.
Hmm.
But I have to admit, we've covered so much already. My brain needs a minute to process it all.
I hear ya. We have been diving deep into these fundamentals, but remember, this is just the beginning. There's so much more to explore, like the nitty-gritty of training these models, figuring out how to evaluate their performance, the whole process of deploying them into real-world applications. Buckle up. We're just getting started.
All right, you've convinced me. I'm ready to go deeper. Lead the way.
All right, let's shift gears a bit and talk about how we actually train these massive models. It's a computationally intensive process, no doubt, but the results are, well, they're worth it. Think of it like this. We're setting up the model to play a game where it learns by making predictions.
A game. Okay, that sounds a lot more fun than I was imagining. What kind of game are we talking about here?
Well, there are a couple of popular games or objectives that we use for pre-training. One is called masked language modeling. Imagine taking a sentence, right?
Okay, yes,
And we randomly blank out a few words.
I'd like them out.
Yeah. The model's task. Try to predict those missing words using, the surrounding words as clues.
So it's like a giant AI-powered fill-in-the-blanks quiz.
Exactly. And by playing this game over and over again with massive amounts of text data, the model really starts to develop this strong understanding of language, how words relate to each other.
Makes sense. Are there any other games these models play to learn?
Oh, absolutely. There's one called causal language modeling.
Causal language modeling.
Yeah, so here we feed the model a sequence of words and ask it, what's the next word in the sequence?
So it's trying to guess what someone's going to say next.
Mm.
I feel like I play that game every day in conversations.
Haha, it's more common than you might think. Both for humans and for AI. And by training a model with this objective, we can create systems that can generate this really natural sounding, coherent text like you see with ChatGPT.
Okay, that's pretty wild.
Mm.
So the model's playing these games, it's learning from its mistakes, getting smarter over time. But how do we actually measure that progress? How do we know it's actually learning effectively?
Ah, that's where evaluation comes in. We need to regularly test the model using a separate set of data it hasn't seen during training.
Right.
This helps us understand how well it can generalize what it's learned, new situations, how it might perform out in the real world.
So like a final exam for our AI student
Hmm.
to see if it's been paying attention.
Exactly. And just like with human students, we use different kinds of tests to evaluate different skills. For language models, common metrics include things like accuracy, perplexity, and BLEU scores. Each is designed to measure a different aspect of the model's performance.
All right, I'm starting to feel like I could actually train one of these models myself. But let's talk about fine-tuning. How do we take this broadly trained model and make it a specialist in a specific area?
Okay, so think of fine-tuning as giving our highly educated AI grads some specialized on-the-job training.
On-the-job training.
Yeah, we take that pre-trained model and train it further. This time, though, on a smaller, more focused data set. A data set that's specific to the task we want it to perform.
So let's say we wanted to create a chatbot, but specifically for customer service. We'd fine-tune our language model using a data set.
Customer service conversations.
Yep.
Exactly. Transcripts of chats, emails, phone calls, anything that can help it learn the language, the tone, the problem-solving skills that are really unique to that field.
And what if I wanted to use my model to, I don't know, generate photorealistic images, let's say,
Yeah.
of landscapes?
Well, then we'd fine-tune it using a large data set of landscape images and descriptions of what's in each image. That helps the model learn the visual patterns, the characteristics that make a landscape a landscape.
Okay, I get it. Fine-tuning is about tailoring the model for a specific job. But do you still need those massive data sets like you use for pre-training?
Fortunately, no. Fine-tuning usually requires much smaller data sets. Remember, the model already has that strong foundation of general knowledge. We're just building on top of that.
That's good to hear. Collecting and preparing those massive data sets sounds like a real pain.
It can be, but the good news is even with smaller data sets for fine-tuning, quality is still really, really important. We have to make sure the data is relevant, accurate, and it represents the specific task we're trying to solve.
That makes sense. So we've covered pre-training, fine-tuning, and evaluating how well our model is learning.
Yeah.
What else should I know to really become a foundation model expert?
One thing that often gets overlooked is the importance of truly understanding the problem you're trying to solve with AI.
Okay.
It's not enough to just throw data and computing power at a problem. You need to be, thoughtful about the specific challenges and nuances of that task.
So it's like being a detective.
Yeah.
You need to gather the clues, analyze the situation, and come up with a strategy before you can crack the case.
I love that analogy. So if you're, building a model for medical diagnosis, for example, you need to understand the complexities of medical language, the subtle differences between conditions, even the ethical implications of the decisions the model might be helping to make. It's not just about building a cool AI system. It's about using AI responsibly and effectively to make a real difference.
That's a great point. It's not just about the technology itself. It's about how we apply it to solve real-world problems. And speaking of real-world applications, let's dive into how we actually deploy these models, put them to work.
Let's do it. All right, so we've talked about building these models, training them, even deploying them, but now comes the really important part. How do we make sure we're using this technology responsibly?
Yeah, that's a big one. We've touched on responsible AI development, but what are some concrete steps we can take to ensure that these powerful systems are used for good?
Well, it's a question that's on everyone's mind in the AI community these days. There are no easy answers, but one thing we can focus on is transparency.
Transparency.
Right. We need to understand how these models are making decisions, what data they were trained on, what biases they might have picked up along the way. Without that transparency, it's really hard to build trust or even hold these systems accountable.
So it's like shining a light into that black box of AI, making sure we can actually see what's going on inside.
Exactly. And that's where things like explainable AI or XAI come in. It's a whole field dedicated to developing techniques and tools that can help us understand the reasoning behind AI decisions.
That sounds incredibly important, especially as these models become more powerful, more integrated into our lives. What else can we do to ensure that AI development is responsible?
Well, another critical aspect is fairness.
Fairness.
Yeah. We need to be really careful about the data that we use to train these models. If the data itself reflects existing societal biases, well, the model is likely to perpetuate those biases, and that could lead to unfair or discriminatory outcomes.
That's a scary thought. We definitely don't want to create AI systems that are just reinforcing existing inequalities.
Absolutely, and that's why it's so important to have diverse teams working on AI development. Teams that represent different backgrounds, perspectives, lived experiences. That can help ensure that those potential biases are identified and addressed early on.
Makes sense.
Yeah.
So diversity in the tech industry isn't just a social good. It's actually essential for responsible AI development.
Exactly. And it's not just about diversity within those tech teams themselves. We also need to think about the diversity of the data that's being collected and used to train those models. The data needs to be representative of the real world, reflecting the full spectrum of human experiences.
Wow. I'm starting to realize that responsible AI development it's a really multifaceted challenge. It's not just about the technology. It's about the people who are building it, the data it's trained on, and the impact it has on society as a whole.
You've got it. Responsible AI development really requires a holistic approach. We need to consider the ethical, social, and even the political implications of this technology at every stage of the process.
Well, I feel a lot more informed, a lot more empowered after our deep dive today. Thank you so much for sharing your expertise. This has been an incredible journey.
It's been my absolute pleasure. I'm so glad you found it valuable. And remember, this is really just the beginning of the conversation. The field of AI is constantly evolving, so it's important to stay curious, keep learning, and never stop questioning.
And to our listeners, we encourage you to do the same. The future of AI is, well, it's in our hands. Let's work together to shape a future where this powerful technology is used for good, benefiting all of humanity.
Couldn't have said it better myself. Until next time, keep exploring and keep asking those tough questions. This is just the start of an amazing journey into the world of AI.
And that's a wrap on this episode of The Deep Dive. Thanks for tuning in. We'll see you next time for another deep dive into the fascinating world of knowledge and ideas.